Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Reading documents with LLMs in Langchain. 3 ways to interact with vector stores. If you are new to Langchain and large language model ecosystem, I would suggest that take a look at Learn About AI Language Models and Reinforcement Learning playlist in my YouTube channel. You will come up to speed in no time. Documents as vector stores. First and foremost, what is the difference between documents and vector stores? Please keep in mind, the documents that we are talking about is right now, the documents that we are talking about is the real world documents that is made of text, pictures, and handwritten data. And vector stores are text embedded as vectors, that is numbers, by various algorithms. For an example, we have Hugging Face embeddings, we have OpenAI embeddings. If you have not understood what is embedding still, or tokenizers, etc., I will be attaching one of the recent videos that I uploaded on this very specific topic. Take a look at that. That is very important concept that we need to understand. The document that we have in real world, that is in text format, is converted into vectors, and that is stored inside a kind of a database called as index database, and these databases are called as vector stores. There are many different types of vector stores available, almost 10 to 12, I think it's about 8 to 10 different vector stores. We will be using ChromaDB, which is a version of DuckDB that we can access through Python abstraction, Python object abstraction. In order to interact with the documents, as I was telling, we are going to read the documents with large language models. Now you know that the documents, that is the real world documents, are converted to vector stores, and in Langchain, inside the Langchain library, we will be directly interacting with the vector stores, these objects, the vector objects we will be interacting with. There are a couple of ways to do this. One is using retriever chain option, which is under the Langchain.chains module, and also there is a plain option of using chains that you can actually pull from the Langchain hub. I will be showing it in a moment. And then we can use tools and use agent executors to run the multiple vector stores and call multiple vector stores based on the description. Okay, if you are wondering about how to use the Langchain hub tools, Langchain hub chains, then I have already created a separate video where I discuss all the options there. The Langchain hub, I will be showing it in a moment. If you go to the internet, you can actually see that there is a GitHub repo called Langchain hub. Under that Langchain hub, you will see the various chains that is available. So you will see there are lots of chains available, and if you go to the Langchain documentation, you will also see the same chain. So at the bottom you will see LLM match, checker chain, you will have the bash chain, request chain. All this are coming from here. So you can see the relations internally, and like that we have agents also. If you go here to agents, you will see the agents, the zero self-ask with search, zero shot React conversion, zero shot React description, and zero shot React SQL. All this are actually written as JSON file, and you can actually read the JSON file here also. And the JSON files, once you look at it, you will understand, okay, JSON file for agents are actually prompts. Okay, and if you go back to but the prompts that are written in a specific format, that is more important. If you go to the chains, and you will see that the chains are in YAML format. Most of the chains are written in YAML format, and for an example, if I take QA with sources, let us take the chain. There are multiple options there. Map reduce, let us go into map reduce, and if you see the chains.json, it is written here in the JSON format, and you will see that the various options that has been provided to that. The point I trying to make is that most of the functions that you see here has been modularized already, and we can also make our own functions depending on the application that you are trying to build. We can actually make our own functions also. So do try to understand how to load the chains like this and how to create the chains. It's very simple. Once you start experimenting with it, you will understand in more detail. Chains is only one way. Okay, so let me go to the presentation again. As I was telling, the usage of chains is only one way, but we can use agents and tools more effectively. So I had taken a video where I spoke about agents as thinking tools. So agents are prompts, as I showed you a moment ago, and the tools that we can write inside the Langchain library can be Python functions, or it can be vector stores. This is what we are going to see in this video, how we can convert agents and how we can actually use the vector stores as a part of agents. Without further ado, let us head to the practice notebook. You will get some clarity there, and also most important thing is do practice, guys, because at the end of the day, providing an environment where you can get access to the compute resource and also the data sets, the code, etc., is to make it easy for you guys to practice, change the stuff inside the notebook, and copy the stuff. You can use the video along with the notebook and see how the things are working out. And if you have any questions, you can raise it in the comment section. I hope that you like this video, and do leave a like and share it and subscribe to my YouTube channel for further Langchain and Python related discussions. With this, guys, I would like to go to the browser back, and I am going to enter into the document analysis. Okay, so if this particular notebook, I have already executed the basic libraries, so I have already pulled all these libraries. You should also pull it in your case. And I'm installing OpenAI and tick token. This is required as we go further down. And this particular area, you can actually remove these 4 lines. You don't need it. Just put your OpenAI key here. Okay, but my keys are inside this. File, so I had to keep it safe, so I had kept it there, and I used config parser for that. I'll be using the space shortened CSV file for working with this example. So this is how the file looks. It is a series of 12 rows made of multiple columns. What now we are going to do is we are going to start by loading the text file that I showed just a moment ago. And once I load the text file, I can actually start working on the documents. Okay, the documents that you see here is not the documents that we spoke about, so that's why I was telling again. So this document is not the text document. So let me do a type, and let me show you what this document is. The most important aspect of Langchain is that start using types continuously. So you will see that by looking at the type of a particular variable, you will understand a lot about it. So you see the document here is basically list. We started by with using a text loader, and once the document got loaded, it became a list. Now inside the document, if you try to explore, so I am actually showing you what to do to understand better. Okay, so you might actually use a different way to understand also. This is the way I use to understand the types more clearly and to understand the data structure inside the object. This is much more easier. So you can see the data structure by visibly. When you see the data structure visibly, then it is way more easier to do your algorithm and do your problem solving by looking at it. It's not how we solve the problems in when we are actually trying to solve it when we learn, right? That's not how it works. You can actually look at the data structure and then you can decide how to solve it. So keep this in mind. So here you see that it is a list of documents, okay, and it's a single single element. There is not much elements here. That's a single element. I have not split it. So you will see that it will be split in a moment. I will be using recursive character text splitter, and I am using this format. I have discussed about the text splitters in the earlier video. I have already discussed about that. I'll be linking that video with this video also. So I'm going to execute this, and now what will happen is this recursive splitter, this object will help me to create the documents. It will split it, and now you will see that there will be multiple documents. So now if you check it, there will be multiple documents. You can actually do a length function also. If I do a length function here and I remove this 0, you will see that there will be more documents. It will not be single element, because now I have split the documents. There are 18 documents right now. This one document became 18 documents, and this is all inside the Python object list. Next, I have the documents in my hand, but they are still text in nature. They are not still ready for fed into the large language models. For that, I need to take the support of OpenAI embeddings. Currently, OpenAI embeddings works very effectively with the Langchain ecosystem. The Hugging Face embedding and the Hugging Face embedding, Cohere embedding are also available. We can also use them. There is an entire series of embedders available here. If you go to models, you can see that. The challenge is that, keep one thing in mind, the embeddings that you are using, if you are going to use OpenAI embeddings, then only you can use OpenAI large language models. They are actually linked. You cannot use Hugging Face embeddings and send it to OpenAI large language model like TextDaVinci. It will not work. Both the things are linked, like the embeddings and the large language models are linked together. You cannot actually break it and do a different kind of embedder and a large language model. It's not allowed. The reason I know that is because I tried it, so it doesn't work that way. The point here is that once I execute this, what is going to happen? The documents that we created, the recurse document, is going to be sent to OpenAI embedding API, and then the document is going to be split, and it is going to be stored in this particular directory. So you will see that index folder here. It will be stored inside that. So that is why it is called as index data store or vector store. So we see that this is actually a vector store object, and now you can start doing the similarity search here. This is a part of similarity search, is a part of vector store vector store class, and also you have similarity score with similarity search with score method also. This particular methods don't need any of the large language model support. It is purely mathematics. So now this is all the basics. We have come to a level where we have the vectors with us, and that is actually stored inside the database called as vector stores. This is the step where we are going to interact with that vector stores, that in using that method we can actually interact with the documents itself, the text document itself. This is the very basic way of using the interacting with the vector stores by using the load summarize chain or various chains that is already available. If you go to the models, you will see that inside the chain you will see that we can actually use the analyze document, we can use transformation chain, and we can use the various question answering chains and summarization chain also. So if you click any of these options, you will see that we can use the chain directly. So from the module summarize, we can use load summarize chain, and we can start working on the type of activity we wanted to do. Okay, but in this case the only issue is that we can only work with one document. Okay, we can only work with one big document. Okay, and this is not very helpful for us. This is actually a text file. You see this is a text object that has been pulled from here. Let me show you. So this is the text object. I am not using vector stores here. I'm using the text object, and I'm directly trying to interact with it using the large language models. So this can create a lot of challenges. So, and also you cannot control the number of tokens that is being sent. So do avoid this option as much as possible. The control is much lesser. We have better options. The next option is that we are using the Retrieval QA option. There is a very good discussion about the Retrieval QA on the blog.langchain.dev. So if you visit, I will be sharing this particular blog also with you guys. Do follow this blog, and they give a lot of information about this. I was reading about LLMs and SQL recently. So this particular Retrieval blog explains a lot about the discussion that I am having here right now. So Retrieval QA, the Retrieval question answer class, helps to work with the chain and also work with the vector stores. Now we are working with vector stores, not with plain text file, right? And we are using the fact LLM, the OpenAI LLM that we created here, and we are going to query it as a chain. So we can run a query and you will see that it replies properly. The point here is that we are not going to send a huge amount of data to the OpenAI embedding or the OpenAI large language model. So as I was again reiterating that when you are learning these technologies, ensure that the file that you are using is small in size. The number of lines, keep the number of lines inside the text file to less than 10 to 15. In that way, you will have better control of how many tokens you are sending to the large language model like TextDaVinci. Okay, so we saw that we can use the Retrieval QA here. The benefit of this Retrieval QA is that you can actually have multiple Retrieval QA objects like QA1, QA2 with various vector stores. So you can have plain chroma 1, plain chroma 2, plain chroma 3. So you can have multiple vector stores and you can actually chain them inside the agents. So there is a separate video where I have already discussed this point. So you can take a look at that, and you can actually understand that by I will show it in a moment. So by using the appropriate description, you can make the agents to call, you can make the large language model to call the appropriate vector stores. Okay, I will be showing an example in a moment after I complete this inside the Langchain document. So stay tuned for that. So here we saw how the Retrieval QA is used with vector stores. Next, we are going to use agents. We are going to use the vector store and create agents, and then we are going to use the agents to we are going to use agent executor to execute the code. So basically what we are trying to do is we are trying to make the vector store that you have got into an agent object, and then we are going to send it, we are going to make a toolkit out of it, and we are going to call the toolkit. So agents can work only with the toolkit, it cannot work with the vector stores directly. So keep that in mind. That is why we are converting the vector stores into toolkit. And once you convert the vector stores into toolkit, you can send it through to the agent. Why, if you are thinking, okay, why agents cannot work with directly with the vector stores? Because agents are prompts. In order for the prompts to actually see the text file, it cannot be actually vector stores, it has to see the text file. So for that, it has to be sent through the toolkit object. So there are lots of, as I was explaining, Langchain has removed lots of complexities from our view, but in reality, when you look at look below the the abstraction layer, like how I showed in the Hugging Face Langchain Hub GitHub repo, you can actually get a lot of information. So you will see that there are a series of prompts that you can also take a look at it. Okay, you can review this. This is very important that you understand how these prompts are loaded also. So there is a very good explanation here. You can take a look at that. Once you create this the toolkit, then you use agent executor.run. What will happen is it will again call the vector store info that we created using plain chroma. The point here I wanted to highlight is this, that we can give a name for the vector store and we can actually make the description for this. The description will contain what the data is about or the vector store is about. So here it is about recent spacefarers data. So whenever any question related to space or space destination comes, it will immediately resort to call the spacefarers data. This is how agents work, and in this way you can control the data that is getting called. This is what I was telling. In case of using the retrieval QA and in case of using agents, you can have better control. In case of the regular the load summarize chain, you cannot actually have multiple documents connected to it, and it will be a one big document also. It will not be split. So it is very challenging to work with such a big document. Again, these are all the ways or the options available to us. The same thing can be done in multiple ways. So if one way is not working, we can use another way to solve the problem. And also, save the day. Finally, the idea of sharing all these concepts is that you might face one or the other problems, and you will know, okay, which heuristics to choose and solve the problem. You don't need to reinvent the wheel. What I've been seeing is that when I was looking around around the various forums and channels, Discord channels and YouTube channels, people have a misunderstanding about various concepts of the objects, the methods inside the objects, and the functions that these objects can do. That is why I wanted to go in detail about the options available and also show the various resources already available out there that you can use and learn do better products. Finally, the objective is finally to create awesome products that our customers and our users will really delight in using, and large language models makes it really possible. And I'm really grateful for all the developers, Langchain developers, as well as the large language model developers, all the open source contributors also. You should also be grateful, and I want to take this opportunity to say thanks to everybody for watching this video, and also for creating such a great technology. That is one of the major things that we are right now enjoying it. So most important things, guys, the point of sharing the collab notebook, making it easy for everybody to get a compute location, is to practice, so that you can actually find the challenges more easily, and you can actually break the things very easily. I mean, it's a Jupyter notebook, so if one Jupyter notebook stops working, then you can just close it and open it again, so you are not going to lose anything. And second benefit is that if you have any challenges, you can immediately post your comments in the YouTube video, and I will try to provide the feedback as soon as possible. Do leave a like and subscribe to my channel. I will be further discussing on additional topics on Langchain, as well as the Python ecosystem surrounding Langchain. As the things are getting sped up by the plugin options that has been released by ChatGPT, there is more and more information to be shared and more ideas that is actually getting circulated. So do stay tuned for next video and subscribe to my channel. And with this, guys, I would like to take a leave as usual by saying 4 words: practice, 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 practice. See you guys. Have a great time.